Hi everybody, Lake Wenatchee here in central Washington. This is the crystalline core of the North Cascades. This is another Bedrock Geology episode. Yes, I'm using the old field guides yet again, but now I'm north of Mount Stewart and I want to learn about this Lake Wenatchee area. I hardly know anything, hoping to learn some things with you today. Thanks for joining us. Let's get started. So if you've been with us the last few videos, I have been learning step by step using field guides from the Geological Society of America, especially when the GSA holds an annual meeting in Seattle. And I was mistaken a few videos back when I said that after the 1994 GSA annual meeting in Seattle, there wasn't another annual meeting in Seattle until 2017. Well, that was wrong, and I was reminded of that by Bob Miller. So Bob Miller in the last video, after we got done filming, said, well, where are you headed next? And I said, oh, I think I'm heading up by Lake Wenatchee. And he said, well, you're going to use my, my 2003 field guide from the Seattle meeting, the annual Seattle meeting. And I'm like, wow, really? I guess I forgot. I didn't go to that meeting for some reason, even though it was hosted in Seattle. So from Bob a few days ago, I've been given this field guide from 2003. And so we're going to follow it, as well as a few things that are in this older 1999 volume. But it's the same idea, following things. Boy, we got a little breeze this morning, so I need paperweights. So even though we're fighting a little bit of a breeze, let me remind you, this is what I was doing with Bob Miller on Monday, a few days ago. And we were looking at the hook and the stem and the mushroom of the Mount Stewart batholith, realizing that it's not all the same age. Go from 96 million year old Pluton material down to 91, which makes up the main stem, down by the Windy Pass. So pink is Mount Stewart batholith, green is Ingalls ophiolite, and gray is the Chewaucan schist. Well, the dominant bedrock geology here is the Chewaucan schist at Lake Wenatchee. Let's find another map to show you that. Okay, among the kayakers on a windy Lake Wenatchee, I'm starting to think that that is Dirty Face Mountain. And if it is, that helps us, because here's a map from the 1994 guide that I like. Lake Wenatchee, I'm on the southeast tip of Lake Wenatchee, looking northwest to Dirty Face Mountain. And it's not just a mountain, it's a Pluton. Similar in age, I guess, we need to read, similar in age to the Mount Stewart batholith. And all this gray, I've chosen gray for all this Chewaucan schist that the Plutons are coming up through, and I've chosen to lump the Wenatchee Ridge gneiss in with the Chewaucan schist. And Bob suggested that. I was actually asking Bob for some colored pencil advice. Oh, we got dogs, we got jet skis, we got everything going on this morning. It's just nice that everybody's out and enjoying the natural world, wouldn't you say? So yellow are roads, and I'm going to leave Lake Wenatchee. I think I'm going to drive, pretty sure I'm driving up the north shore of Lake Wenatchee, and then we'll do a little bit up the Little Wenatchee River, we'll do a little bit up the White River, and ultimately we'll see if we can get up to the 10-peak Pluton, at least a rock outcrop of it. And I'll combine this field guide, which I'll tell you more about, from 1994, which is not Bob Miller. We'll combine that with a 2003 Bob Miller field guide. Okay, so Lake Wenatchee, basic orientation. Let's get on the road, get away from people, and start looking at some detailed bedrock. This is the White River. We're out of the wind. We're into the trees. Surprisingly mosquito-y here. I feel like I'm in Wisconsin, for crying out loud. I'm not far from Lake Wenatchee. And as opposed to Lake Wenatchee, which was an incredibly busy place with people everywhere, not far away, me, myself, and I. Feels great. Don't drop this in the river, boy. Don't drop it in the river. Don't drop it in the river. I don't know this fellow, Jerry McLaughlin, who back in 1994 was, I don't know, a professor or a finishing PhD student from University of Michigan. So let's give you a little, this is the road we're about to head up. Let's give you a sense of where we are. Swinging south, downstream, White River. It's a little bit of a junction. It's a nice little opening here. The bugs aren't quite as bad right at this spot for some reason. And bridge built in 1965. Ha! Okay. So up ahead 4 miles is Tall Timber Ranch. So I went up that road once and only once to drop off a 5th grade son and some of his friends at a 5th grade camp, Tall Timber Ranch. Ha! Totally forgot about that. So I've been here once and only once, and that kid is now 26. We're looking at, my God, I'm getting eaten alive. What is this, northern Wisconsin? Yeah, here we go. So notice how Lake Wenatchee is basically straddling. So this is today, right? This is not a terrain, this is the actual lake. I never had that before. That the bedrock surrounding the eastern half of Lake Wenatchee is basically, oh, wait now. No, it must be Chumstick Formation. Eocene sandstones. Yeah. And then to the west of the Leavenworth Fault, suddenly we're in the crystalline core. Here's an anticline within the Chewaucum schist. Notice I've colored everything gray now in here, including the Nason Ridge gneiss. I'm starting to learn about dirty face Pluton, which is lopped off by the Leavenworth Fault. Interesting. And our goal is to at least get a little casual look, a first look at the 10-peak Pluton. So I've colored these all the same. Mount Stewart, Dirty Face, 10-peak. I don't know. We're not going there today, but the Sloan Creek Plutons, never heard of them till right now. I don't know if people still call them that or not. Are these all 96 to 91? Plutons? Is this the same story, in other words? That's really my ultimate goal today. And I don't know how much more I'm interested in the Chewaucum schist, to be honest. I've seen enough of it over the last couple of years. I know it's complicated. I have the same general area that there's a maximum age of 120 million years ago. But if we're approaching a discussion this winter of Baja, BC, and we are, it's the Plutons that suddenly have more interest to me than the exotic terrain country rock. Now, I might change my tune, but that's kind of where I am right now. So I think we're in the gneiss that's in this kind of gray Chewaucum. That's all I'll just call it now. From this point on, we'll just call it gray Chewaucum. And you know what I mean. It's a combination of schist and gneiss. Okay, right down by the road. Whoa. Wow. I don't think there's a field trip stop right at this bridge. I'm surprised there isn't. Man, this is nice. Well, Of course it is. Well, let me read at some nearby field trip outcrops and see. It's just like, what is this stuff? I mean, I think there's a whole metamorphic petrology course tucked into this Chewacam gray. You know what I mean? Remember, there were three generations of metamorphism within the Chewacam. And even though this is, I think, technically the Nason Ridge gneiss, same fold pattern, same general story as far as I can tell. I'm not going to scramble all the way up, sorry. Oh, nice. Huh. Bunch of muscovite. You see those white flaky things? Otherwise, not totally sure what I'm looking at. Although I think I saw this in Jerry's. He stopped a little further up the road, but let's try a couple more of those. Yeah. So clearly not a simple Pluton. You're like, why not? It looks like a granite to me. Well, I don't know, does it? There's some banding here. There's some foliation. Maybe more obvious when I don't break open a rock. I think there is. This isn't the dirty face Pluton, is it? Well, we're back to that interesting, this is interesting to me now. So after learning from Bob directly and also by what he and Scott Patterson were writing 30 years ago, let me flip you around. Okay, well, I'm starting to think that it's not the two end members that I have in my head. In other words, if you're in a Pluton, it's just this absolutely perfect plutonic igneous rock without any foliations or any strain indicators or anything. It was just this nice, blobby, this bloop of stuff. And then in my simple mind, the country rock is this heavily folded, super organized, complicated, but all these metamorphic minerals that are pre-existing essentially. And so here comes this kind of, this squirt of cream filling coming up through this fruitcake that's already there. Well, I'm starting to realize that in a Pluton, you can find a continuation of something like the Windy Pass thrust, where you can follow a fault zone with potentially some significant offset or displacement along that fault. And so the Plutons are not just simple, randomly arranged minerals. I guess I kind of knew that, but I'm starting to realize that more and more. And maybe the opposite end of it is true as well, that if you're dealing with some of the metamorphic material, there's some older Plutons maybe that kind of mask some of the folds and the structures that existed before. Okay, no surprise, the North Cascades is complicated, but even on an outcrop like this, let me flip you back around. Okay, so Jerry says we've got the White River ultra basic body. Mostly strongly foliated with elliptical chlorite patches. Elliptical chlorite patches. Down dip lineation. Okay, I'm getting lost in the weeds already. Olivines in the rock at a fine grain scale. Yeah, okay, well, let's see if we can see some of that. Robert Gates, University of Wisconsin. I lost interest once we got into the weeds. That's just me, I guess. I know many of you just like looking at pretty rocks, and this would be a good place if you want to see some of this. Well, it is handsome. I'll grant you that. Micaceous metamorphic rocks. That's how I would lump this stuff, and no shortage of it. Okay, let's head up the road. Thank you. I don't know. Should I bust this green thing? Hiya! Hello. Hello. A little sugary, almost a quartz vein or nodule or something. I thought that was a garnet. Yeah, hand samples. I might keep this one. Hand sample size, kind of a blonde, micaceous, lots of muscovite mica just flaking off of this thing. But on a larger scale, we can clearly see things are banded. Yeah, okay. Let's move on. Okay, great spot. Give you a GPS location for this. It's on a Forest Service road. The White River is down low. Really good look at Dirty Face Ridge, or Dirty Face Mountain, or Dirty Face Pluton. No idea if we're going to talk a fair amount about Dirty Face Pluton this winter, but if we are, there it is. Let's do some reading back at the car about what we know about the age of that Pluton. I'm curious now. But this good Forest Service road, not very many miles away from our last stop at that intersection, has some absolutely breathtaking outcrop. I don't know. Let's go 1994. See what Jerry's got to say about this. He's a little less verbose than Bob. Jerry McLaughlin. Variety of outcrop scale structures developed within the Chewaucam schist and the gneiss. The regional foliation dominates, striking generally northwest or more westerly where folded and dipping steeply to the northeast. Budens, I don't care. Bob Miller, 2003. Same outcrop. Chewaucam schist, Nason Ridge, Migmatitic gneiss, contact, and overview of Dirty Face and Ten Peak Plutons. Oh, well, I don't know if, oh, maybe that peak is Ten Peak. That's cool. Complex folding, shearing in the schist and gneiss. Fabrics. Orthogneiss, meaning gneiss that used to be granites, basically. Okay. Let's keep it going. Parasitic folds, major folds, Budens. He's referring to McLaughlin's 1994. Okay, at least 20 years ago, they're confused. Bob's confused about the structural setting, the significance. White River Shear Zone. Okay, that's the first time we've dealt with that. I need to learn more about it. The White River Shear Zone's not far away. Okay, I might back off of this, but right now, when I see the phrase shear zone, like the White River Shear Zone is just right over there, I think strike slip fault. For instance, most famous strike slip fault in the world, probably San Andreas Fault in California. a brittle break at the surface where a portion of California has been shifted northwest compared to the other side of the fault. Using piercing points, you can restore that San Andreas Fault strike-slip fault. Okay, fine. We're going to be doing that this winter with places in the North Cascades. But what is it like when you go deeper into a strike-slip fault area? What does it look like along the San Andreas Fault, for instance, today if we're 5 kilometers down, 10 kilometers down, 20 kilometers down, 30 kilometers down? I don't know. But the temperatures and pressures are higher. The rheology of the crust is different, isn't it? It's not cold and brittle. It's warm and kind of ductile, but it's still shearing. In other words, it's still being moved by the strike-slip fault, but it looks different. The deformation in the crust, maybe it's mushier. I don't really know what I'm talking about now. But when I read about the strike-slip faults in the North Cascades, that makes sense to me. But I think for now, I'm in a strike-slip fault zone, but it's called a shear zone because we are in a place where the strike-slip fault was deforming the crust sideways like taffy instead of frozen taffy. And since the activity on the White River strike-slip fault, there's been uplift in the Eocene to show us these offset rocks. Okay, back to the program. Thank you. Rocks in the gneiss nearby and pieces of that gneiss within the dirty face Pluton have porphyroblasts of garnet and kyanite plus or minus some staurolite. Thermobarometric results, I don't know what I'm talking about now, for these rocks are some of the highest pressures, up to 9 kilobars, determined in the Chewacam schist. Garnet growth was near isobaric, beginning at 545 degrees centigrade and 7.1 kilobars of pressure. No data directly constrain the timing of this oh, really? We don't know when the metamorphism happened, but it's assumed to be younger than the Mount Stewart Pluton and correlating with some sort of 88 to 86 million year old. You flip you around again. So that's a little bit of a struggle right now. I don't know how important it's going to be for Baja, BC this winter, but there's so much. Well, I'll get some help from Stacia Gordon and Bob Miller again in early August. But I'm going to be asking essentially, what's the story behind this metamorphism? I mean, we have metamorphic rocks all through the crystalline core. Fine. We have high temperatures, high pressures. We know certain depths. Okay, fine. But I think from my point of view, and I don't know if it matters that much, but from my point of view, like, why are we having that metamorphism? As a Geology 101 instructor, I'm thinking about what I tell my students. There's 3 styles of metamorphism. I'm not embarrassed to say this. The most intuitive way to me out here is that you have rock that's near a very hot magma body, a big Pluton invading from below, and you alter or metamorphose that rock. So you have contact metamorphism around, like those aureolas that we were talking about last week. God. But there are 2 other ways to make metamorphic rocks at the Geology 101 level. One of the ways is you have a tectonic collision, dynamo-thermal metamorphism, and you're jacking up the temperatures and pressures because you're in the middle of a collision. Do you remember last winter? Talking about the insular superterrane? Rangelia and friends? A major collision with this thing out in the water roughly 100 million years ago? Are the metamorphic rocks that I'm looking at right now, right across the road, a direct result of colliding with Rangelia and friends? The third way is you do burial metamorphism, but that seems too passive a process for this scene. So just thinking out loud right now, when I look at all these metamorphic rocks this summer in the high Cascades, the North Cascades, I guess I'm constantly going to be a pain about it and asking you and asking Stacia Gordon and Bob Miller, can we tell if the metamorphic activity here is from a result of the Plutons invading or from a regional collisional thing? Never thought about that till right now. I kind of like it. We'll see if I like it later on. All right, let's go look at some rocks across the road. Thank you. Yeah, it's, oh wow, yeah. So it's tantalizing to, I'm sure Bob and others have been here kind of measuring these foliations or these, like miniature, if you don't know what foliation is, it's like measuring the patterns within a kind of swirly metamorphic rock. And then doing something with those patterns. Saying something about, boy, I'm starting to wonder, is this a, man, is all this metamorphism the result of colliding with a super terrain? Why didn't I have that question before? Like, that's way more interesting, isn't it? That's way more exciting than just having a red hot blob come up from below. I mean, that's interesting. Like, why is the red hot blob coming? Is that a slab failure thing? That sort of deal. But well, that's a cute sample. Let me get up there. Yeah, I like this one. It's in the shade too. Yeah. Yeah. A little too weathered. Looks similar to the Chewacum schist that we were doing a couple of videos ago. I don't know. I like this sample though. Let's try one more. Yeah. Oh, broke right along a foliation. And therefore we can't see much. Yeah. Yeah, this is more typical, even in that septum over on the other side of Stevens Pass where the bigger crystals were. I don't see huge crystals, by the way, here, do you? You're like, magnify me, maybe I can. Yeah, we're bordering on gneiss here, right? Metamorphic gneiss as opposed to schist, but I don't think I care. I think it's the same story. What was I going to do? Yeah, I guess I was just going to remind you that, okay, well, down at this other side of this outcrop, so without knowing much about metamorphic rocks, I'm kind of thinking that the standard looking Chewacum that we've seen to this point is kind of a lower grade version. And then some of this, which is kind of greenish and extra sparkly and a little bit harder to break open and pings a little bit more without knowing much, I'm imagining that as being higher grade or deeper. Isn't it interesting how there's kind of beautiful faces on this outcrop, controlled by the fabric of the metamorphic rock? I don't know, maybe polished by glacial stuff. I don't know, it looks so damn smooth. But yeah, this is, I don't think I've seen a schist slash, I'm not sure I've seen a foliated metamorphic rock outcrop with such an obvious foliation even at the outcrop scale. Yeah, this is beautiful. Look at that. I'm thinking that I'm learning this iPhone does better in total shade sometimes. This works for me as a way to capture a major metamorphic unit in its natural, I mean, just the shape of these pieces that broke off, you know, they're breaking along. I can't hold it. Yeah. Something like this. Okay. Well, this is probably going to work. Chewacum schist. From this point forward, if you see that gray, colored pencil gray on my maps that I'm going to continue to work with and hold up to the camera this winter, this is the stuff I'm talking about. Some of it's truer to a schist, some of it's truer to a gneiss, but it's this kind of well-foliated, banded stuff. Chewacum, quote-unquote, gray. Chewacum gray, in other words, Chewacum schist / gneiss. And then we cross the White River. I think you're looking like southeast or maybe straight east. That's not a Pluton. That is. That's the country rock. Maximum age 120 million years, but definitely here by 100 million years ago. And then this thing, I know it looks similar, but this thing is totally different animal. This is a entire Pluton, the dirty face Pluton that's invading from below. So this is the kind of scale we're talking about. I've parked on the contact between a Pluton and the country rock. I don't think it's an accident. The White River is flowing on the contact between these two geologic units. But maybe this is also going to be helpful for us this winter when we see these Plutons on the maps and we keep talking about these Plutons of mid-Cretaceous age, etc. This is a relatively small Pluton compared to Mount Stuart Batholith or the 10-peak Pluton or some of the others. I'm no longer using Jerry's guide, but I'm using Bob Miller, but we're along this, doesn't matter, we're along the same road. So we've passed Dirty Face Pluton and we're approaching this area here. Okay, well, why are we stopping here? It's not even an official stop on Bob Miller's 2003 trip. But he says, stay to the left at the junction with Tall Timbers Ranch. And here we are at the Ultramafic slice of Napeequa Complex. The Napeequa forms a thin rind between the 90 to 92.5 million year old 10-peak Pluton. That's a new date for me. in the neighborhood of the big flare-up at the end, the 91 million year old flare-up to make the Stewart Pluton and the Chewacam schist. And as we continue up the river, the cliffs of the 10-peak Pluton rise above to the right. Okay, well, I'm looking forward to that because I have no concept of what it looks like to be at the 10-peak Pluton. So, no breeze here at all. Let's leave the papers on top of the car. Need a rock hammer. And then we'll go over and see this Ultramafic of the Napeequa. Now, the Napeequa I haven't thought much about since 2 winters ago, but my only memory is that Napeequa terrain equals Bridge River terrain, and those guys are long travelers through the Pacific. So that's a mind blower. We don't need to go there necessarily, but here we are parked along the side, and we can see there's this Ultramafic Napeequa in spades all the way up the ridge. That's quite a block of it right here. But I don't know if we need to go up much at all to get a sense of it. So this is not a major player, but it is kind of odd to be in some Ultramafic rock that's not Ingalls. We've been in that Ultramafic Ingalls for so long that I'm just curious what this stuff looks like. Yeah. Sparkly. The word chert comes to mind, not when looking at this sample, of course, but when thinking about the Napeequa. The Napeequa deep ocean chert. So, God knows why we have Ultramafics tied to that. Well, I guess I can guess. Just like the Ingalls, maybe this is part of the ocean floor itself, and the Napeequa chert is the stuff sitting on the ocean floor. Well, that wasn't that hard, was it? All right, well, I'm going to get disinterested momentarily. I mean, this Ultramafic stuff is fun when you think of it being ocean floor. But other than that, what's there to look at, really? Well, we were at some Napeequa today. That's interesting. The only other time I was at Napeequa terrain was driving up the Aniat Road, which I suppose I'll be doing next week as I start dealing with the Chelan block. Well, that's another point. This is Napeequa on the Wenatchee block, and I think I'll wait to talk about the significance of the Chelan block versus the Wenatchee block, but just put that in the back of your mind. This is a Napeequa exposure on the Wenatchee block, and that's going to be a piercing point for us. Oh yeah, I'm remembering that now. You know what? Let me show you that map. We've lost the bugs again, mostly. Yeah, okay. All right, here's a reason this is interesting to me. Here's a reason that this, okay, I like this. Here's the reason that this Napeequa here next to the White River, which is right down there in the trees, that same aqua color. Here's the reason this is worth, wow. Got it right here. Close the frickin' car so I don't get full of mosquitoes. I don't know if I'll stick with this coloring scheme. Come on. Mount Stewart Pluton. Sick of it. Chewacam schist. Dealing with it today. Dirty Peak Pluton. Lopped off by the Leavenworth Fault. Remember that. But whatever this color is, let's call it apple green. That apple green is Napeequa. On both sides of the modern volcano known as Glacier Peak. The apple green of the Napeequa on all sides of the 10-peak Pluton. And again, we are just south in the Napeequa of the 10-peak Pluton. The reason this is exciting is that on the other side of the Eniat Fault, there's a bunch more Napeequa. The Columbia River's over here. Wenatchee's down here. So you have this Napeequa, you lose it, and then you find it again on the other side of this major Eniat Fault structure. Significant right lateral offset on the Eniat Fault, Napeequa on the Wenatchee block. Love it. All right, I got more respect for you now, Napeequa. Onward. Okay, I'm almost to the end of the road. Really enjoying following this field guide. This is a place called White River Falls Campground. My God, there's the falls of the White River. White River Falls. Bob Miller on Monday was talking about how much work it was to get into the 10-peak Pluton to get some samples. I get it now. I get it now, Bob. Okay. Well, maybe you can hear me in a decent way. Let's just have a nice little seat here and read what Bob has to say about this stop. The outcrops next to the White River are tonalites, that's a light-colored granite, of the 10-peak Pluton, which are strongly deformed in the White River shear zone. I don't think I'm going to be able to find, I don't know what sea surfaces are. These are all, you know, deformed areas within the Pluton that tell us where this shear zone comes through. Darker fine-grained hornblende-bearing myelinites, best seen at low water level. Well, that's not today. Maybe strongly deformed dikes and or xenoliths of the Napeequa. Ten Peak Pluton. I don't think I'm going to whale away with my hammer. This is a popular place for people to enjoy the falls. Well, I don't know. Maybe, can I get creative here? Yeah. Well, there we go. My God, I made it. Ten Peak Pluton. Let me get over in the shade. Ten Peak Pluton right here at White River Falls. I'm going to hang on to this one. A lot of quartz diorite. I don't see the foliation they're talking about right here, but maybe I just happened to grab a piece that isn't totally within the shear zone. Excellent. Success. Well, thanks for watching today, everybody. We drove today from Lake Wenatchee at the start of this video up here to White River Falls. And these are places that you can get to with an easy vehicle. We don't need a special rig to get up to these spots. There's some dusty Forest Service roads, but what the heck? These places are here and waiting for you. Thanks for watching. I love you, and goodbye.